We hear a lot in the media about fad diets, and you may have even tried a few yourself. One of the more famous ones is the so-called 5-2 diet, also known as intermittent fasting, where the aim is to drastically cut down on calories, but only for 2 days a week. But does the science behind it stand up? A new review of the evidence behind intermittent fasting, published this week in the journal PNAS, suggests that it might. One of the researchers who's been putting this diet to the test in lab mice and in humans is Mark Mattson from the National Institute on Aging in the US.
Our work started in animals, and we found, and others have, that if you have the animals fast intermittently, for example, in our lab we have them fast every other day, so 24 hours no food, then they can eat the next day and so on. They can live up to 30% longer. And intermittent fasting in animals can inhibit cancer growth and have beneficial effects on the cardiovascular system and brain. So we find even in animals that are not exercising, by doing intermittent fasting, we see changes that are occurring in the cardiovascular system that are very similar to what's seen with endurance exercise. We've been wondering, since this kind of intermittent eating diet is more natural, what animals and our human ancestors experienced previously, wondering whether eating 3 meals a day plus snacks is really the best type of eating pattern to maintain health and a healthy body weight.
What would our ancestors' eating habits have looked like?
Of course, they had to work for their food, whether it's if they're carnivores, tracking down an animal and killing it, or if they're more vegetarian, moving all day to get relatively small amounts, say, of fruits or other types of food. And then also there is the issue of sporadic availability of food depending on the season of the year.
The animals that you're looking at in the lab, presumably you can control what they eat, you can control their access to food. What's the evidence that this kind of restricted diet may have benefits in humans, and also how easy is it going to be?
Yeah, so far there's been only a few controlled studies done. I've been involved in several. For example, one in asthma patients, where we took asthma patients who were overweight and had them go on kind of a very severe diet where every other day they only ate 500 calories. We were able to get them to do that for 2 months, and they had very clear improvements in their asthma symptoms. And then the other studies were done with Dr. Michelle Harvey at the University of Manchester, and she works with women at risk for breast cancer because of their family history and also they're overweight. There were over 100 women. They were divided into 2 groups. One group, we had them reduce their daily calorie intake by 25%, so counting calories each day. The other group, we had them 2 days a week eat only one modest meal of about 500 calories. We followed them for 6 months, and we found that both groups lost weight, but the women on what's now called the 5-2 diet lost more belly fat, and their ability to regulate glucose was improved more than the women who counted calories every day.
What do you think is going on from a scientific point of view? Because there's this dogma that we're sort of locked into a daily cycle of 3 meals a day. What's going on at a molecular level that might explain this?
So glucose normally, if you're eating regular meals, is the main source of energy for cells, and it's stored in the liver. And when that's depleted, which usually occurs in around 12 hours, depending on how active you are, then what happens is your body starts mobilizing energy from fat. The fatty acids from your fat cells go into your liver, and they're converted to chemicals called ketones. Ketones are known to be a very good source of energy for cells, particularly very active cells like nerve cells and muscle cells. So that's one major change that happens, probably explains in part loss of belly fat in the women in the study we did. My own work focuses on the brain, so we've critically looked in animals, and we'll soon look in humans at how short fasts, even 1 day, but repeated, maybe a couple times a week, affect the brain. And what we found, the bottom line is, the intermittent fasting, the cells respond by enhancing their ability to cope with stress and resist disease. And we've identified many specific molecular changes that are occurring in the nerve cells that explain that. Much more work needs to be done in humans to determine if and which types of intermittent fasting diets would be optimal for health. But let's say that some particular diet was clearly established, for example, the 5-2 diet, to be consistently beneficial in many groups of people. Then the issue is how to work this type of eating pattern into the daily and weekly routine. And we think that, based on our initial studies, that it may be easier for many people to focus on a couple days a week in reducing their energy intake a lot and then eat normally the other days versus counting calories at every meal every day, which is what most diets are nowadays that people go on, is they count calories. And that psychologically, I think, is much harder than saying, okay, 2 days a week, I'm going to only eat 500 calories. The other days I'll eat normally, but eat healthy.
A lot of people make a lot of claims for things like the 5-2 diet. How much do we actually know from human studies in terms of things like health benefits? Say you talk about reducing cancer risk and effects on long-term chronic illnesses, or is there still more research that needs to be done?
Oh yeah, there's a lot more work that needs to be done. Essentially, we've done 2 studies that have been published, and in both studies, the 5-2 diet improved multiple health indicators over a 6-month period. However, what we don't know is long-term effects, and also how might these diets be applied to people who have some disease already. And in fact, there are studies going on now by several groups, including Dr. Harvey, taking cancer patients when they're being treated with chemotherapy and radiation therapy and put them on intermittent fasting diets. And there's at least 3 different studies I know going on. But based on the animal data, the prediction is that the subjects who fast during the time they're undergoing therapy, that will enhance the effects of the chemotherapy and radiation in killing the cancer cells, because the cancer cells will have less energy available. And also we think the normal cells in the body will be less vulnerable to being damaged by the radiation therapy and chemotherapy. That's an example of the kind of studies that will need to be done.
Personally speaking, do you follow any kind of restricted diet?
Yes, I do, somewhat. Challenging oneself intermittently from the standpoint of energy intake or energy expenditure is good for health. It's well established for exercise. So during exercise, that's a mild energetic stress, not only in your muscles, but it turns out a lot of organ systems, including the brain. And that mild challenge or mild stress on the cells respond in a good way and enhance their ability to cope with more severe stress. I kind of look at the fasting as analogous to exercise, but it's kind of the opposite kind of energetic challenge. It's reducing energy availability over an extended time period, say of a day. My own approach to diet is based on this notion that it's important to challenge ourselves intermittently for optimal health. One way I always look at this is from an evolutionary perspective. Why would it be that fasting would be good for the brain and the heart? Animals and our ancestors that were most likely to survive were those that everything's functioning well when they haven't eaten for a long time, because that enables them to track down prey and catch it. Your mind has to be working well, your cardiovascular system. So all those things seem to tie together in a way that these mild challenges of not having food is a driving force for evolution, and that therefore makes a lot of sense that over millions of years we've developed ways that we respond positively to fasting and to exercise, because those positive changes allowed us to survive.
Mark Matson from the National Institute on Aging. So, based on the animal studies and the limited short-term trials in humans, it looks like the 5-2 approach to dieting could be a good thing. One person who tried it, making a BBC Horizon documentary and writing a book about his experience, is Dr. Michael Mosley. I asked him what it's like being on the diet.
It was about 2.5 years ago, and I went to see my doctor, and they took some blood as part of routine, and then got the call telling me I was a diabetic, type 2 diabetic. And she said, "Do you want to come in and start on treatment?" And I said, "No thanks, I'd like to go and find out if there are ways of treating it which don't involve drugs." And I started researching, and I came across this thing called intermittent fasting, which I'd never heard of before. So I had a chat with the editor of Horizon and said, "This sounds interesting. can we do a program about intermittent fasting with myself as the subject? And he said, great. So we did loads of blood tests on me beforehand, and then I set off and tried a whole range of different forms of fasting.
What kind of things did this involve? Did it mean just not eating anything for ages?
Well, the first I started on was not eating anything for 4 days. So I was essentially just on water. No, I lie, tiny amount of miso soup. It's 25 calories a day for 4.5 days.
That sounds hardcore.
It was actually all right, because initially I thought it was going to be terrible, but after about 2 days I became acclimatized, and it actually had some quite profound effects on my body. So I lost a bit of weight, but a thing we were interested in was a thing called IGF-1, which is a measure of cancer risk, and that halved over that period. And my blood glucose as well, not surprisingly, came down pretty dramatically.
But I guess something like that's not very sustainable long term. So what were some of the other things you tried?
So then I went off and I met Dr. Krista Barrady in Chicago, and she suggested trying alternate day fasting. And on this pattern, what you do is you eat about a quarter of your normal calories, so that's around 600 calories for a man, 500 for a woman, and you do that every other day. And I tried that for a while, and it certainly had some beneficial effects, but I found it quite difficult. I just found the pattern quite difficult to stick to. So I went and saw Dr. Mark Mattson from the National Institutes on Aging, and he showed me some research on the brain, and he also talked about doing it for 2 days. So we agreed I'd give it a go properly for 2 days, and that's what I did.
So how does that work then? What would a week look like for you?
I chose a Monday and Thursday for no particular reason. So on a Monday, I get up and I have some scrambled eggs for breakfast because the protein keeps you fuller, and that's about 180 calories. Then I skip lunch, and in the evening, I have a pile of vegetables and, say, a bit of fish, and that's probably about another 300 calories. So the whole lot adds up to maybe 500-600 calories. So I do that on Monday, Tuesday, eat normally, Wednesday normally, and on Thursday, I kind of do the same thing again, around 600 calories. And I did that initially for 12 weeks. And in the course of that, I lost around 9 kilos. And what was really good is almost all of it was fat. So my body fat went down from 28% to 21%. And best of all, my fasting glucose levels went back to normal. And they have stayed like that for the last 2 years.
As a human being, I go, wow, that sounds amazing. But as a scientist, I go, you're just one person.
Absolutely.
That's not exactly scientific. What does the science say about this kind of approach?
Well, the science is very strong, certainly from the animal data. Dr. Mark Mattson has done a lot of stuff, Krista Barrady has done a lot of things, and Dr. Michelle Harvey up in Manchester has similarly done some pretty big trials. For example, they saw greater fat loss. There were also significantly greater improvements in things like insulin sensitivity and also in inflammatory markers.
These studies have only been done in reasonable short time. Is there any evidence of benefit for health over the longer term?
I think it's too early to say. We know that calorie restriction is the only thing that's ever been shown to extend life in pretty well every animal it's been tested in. There are some long-term calorie restricting humans who actually stick to a pattern of eating 1,600 calories a day or thereabouts. Over many, many years. And what they found there that all the sort of metabolic markers are improved. Until they drop dead, we won't really know.
Obviously, it sounds like a relatively simple thing to do. You restrict your calories 2 days a week. But as a society, we're geared around this 3 square meals a day. How do you think, if people want to do this, how easy is it to get this as part of our culture, part of our eating culture?
I mean, I think the problem is it's not 3 meals a day, it's now 5 or 6 meals a day because people snack all the time. I find that it is relatively simple. If you decide just 2 days a week you're going to restrict your calories and you're not going to have those snacks, then psychologically it's attractive because you go, okay, I'm not going to do it today, I'll do it tomorrow.
Do you find that you then want to kind of bounce back the next day and overeat in compensation?
No, I personally don't, and indeed the studies suggest it doesn't happen. Krista Barrady has done most of the studies in this area, and she thought originally that's exactly what would happen. But in fact, people don't tend to overcompensate. If you do, then obviously you're not going to get huge benefits.
How important do you think it is that we bring science and proper research to weight loss? Because there's an awful lot of stories about it. It's something that preoccupies us in the media and preoccupies many of us.
I think it's absolutely vital. I think we've applied, science to pretty well every other aspect of our life. And I just think that it is hugely important that we look at it on the big studies. Obviously, studies are hugely important, but also trying to understand what's happening at the cellular level. And that's what this paper is all about. It is both a description of studies which have been done with humans over quite long periods of time, but is also about the sort of pathways, and that's what makes it interesting, I think.
How did you feel, particularly on the days when you were restricting your calories? Did you feel lightheaded, or did you just get on with things?
I just got on with things. It's like now. I haven't eaten now for about 7 hours, and I feel fine. I feel a little bit peckish, but actually found that I became more energetic. And the evolutionary perspective on that one is that, we were our remote ancestors, hunter-gatherers. They had feast and famine. If they didn't have food, they couldn't just kind of lie on the floor and wait for food to come. They had to get out there and become more active. And that's kind of what drives you. I think there are lots and lots of myths about food, and one of them is this thing called starvation mode. If you don't eat regularly, then your blood glucose will fall through the floor and you'll feel faint. And it is complete and utter nonsense, along with the idea that if you stop eating, then your metabolic rate immediately slows down. Because the studies I've looked at, where they have taken volunteers, put them in metabolic chambers, kept them without food for 6 days, the metabolic rate actually goes up. It is only in periods of prolonged starvation and when you lose a lot of weight that your metabolic rate goes down. So there is a lot of myths out there which need to be hit over the head.
The thing about the kind of proposals of just fasting is that it doesn't say you have to eat anything particularly, any of these special foods, this and that. This would suggest that you don't have to eat anything particularly special.
I think that on the days when you are eating a restricted diet, 500 or 600 calories, it's important that those are nutritional calories. So I recommend you eat plenty of vegetables. I also recommend you skip the carbohydrates on those days. So it's basically a diet which is rich in protein, vegetables, and either meat or fish or something like that. Or there are options for vegetarians as well, because we know the body doesn't store protein, so there's always a risk that you'll go into negative protein balance if you don't get adequate protein on the days when you are calorie restricting. I think there are lots and lots of really, really bad diets out there, of which the one I hate most is juicing diets, because what happens in those is you go for very long periods on very low protein. And the problem is the body then decides to cannibalize itself. If it can't get the protein from the food, it will take it from your muscle. I think it is important that you actually are aware of the essential nutrients you do need, that fasting, and particularly prolonged fasting, comes with its own problems.
What do you think of the irony that we have so much about diets and exercise and keeping fit and eating this and eating that in the media, but yet still our waistlines seem to be expanding?
Part of the problem is that an awful lot of the advice is terrible. And this is terrible advice not only coming from the obvious fraudsters, but also, frankly, from the medical profession. When I was at medical school, we had almost no nutritional advice whatsoever over the 5 years I was there. I asked a bunch of medical students the same question recently, and they said, no, we get none. We know a lot about malnutrition, we know a lot about deficiencies in vitamins, but if you get an overweight diabetic coming in the room, do you know what to say to them? No. I would love it if a greater emphasis was placed on nutrition in the sort of medical training.
And based on scientific evidence?
Based on scientific evidence, and also being aware that the scientific evidence changes. And the reality is, as in almost any branch of science, you have to keep up with the latest research. Otherwise, you are doomed to be repeating the old mantras that you learned, 25 years ago.
That was Dr. Michael Mosley.